Hello, everyone. I'm Tom Ballard, and welcome to Watermaster's Groundwater Talk Live. Today, we are going to be talking about predictive maintenance for small water utilities. And that's a hot topic these days because it's really gotten to the point where small water utilities can actually take advantage of AI and some of these tools out there to really put together predictive maintenance programs that work for them and really help manage their limited resources in terms of staff and financial resources as well. So we're going to dive in and we're going to talk about it. We're going to go through the steps you need to implement a predictive maintenance plan, kind of step by step, really designed around small water utilities. And then we're going to show you how you can use a spreadsheet to do this and even SOPs, and we'll dive into that a little bit too, so you can see how simple this really is, but the great benefits you can derive from that. So before we get going here, I'd like to ask you to like, comment, or subscribe if you like this information. Please share it out there. It tells us what you like, and we can make more of what people are interested in. So that's how I get to know what more to make of these different programs. So thank you very much for those who've done it in the past, and just keep it up. Thank you very much. All right. So the challenge for small water utilities these days is really that they have tight budgets, they're resource constrained in terms of staff and financials, maybe other places too, limited staff. There's a lot of people wearing different hats out there, and that's something that really is probably most challenging, maybe even more challenging than the financial resources. We also have aging infrastructure, and that's not unique to small water utilities, but it can hamper those utilities. But we see it all across the country. It's not just water systems, roads, bridges, and everything. We're seeing a lot of problems with aging infrastructure. And so predictive maintenance becomes very important because you're looking at how can we best uh, take our limited resources and really focus on where we have both a high consequence of failure and a high probability of failure, and really focus on those assets and maintaining those. So really the answer to the questions is uh, predictive maintenance. And really what we're going to talk about today is a spreadsheet-based systems. Now you can plug in AI to this, and this is kind of what we've been doing. We've been moving more and more to AI to kind of do some of our prediction for us. But even a simple spread-based system with a dashboard set up, and I'll show you one a little bit later in the program, towards the end of the program, how we do this. Very simple. You make it easy to use, so everybody will do it. And now you're taking your own data and you're making data-driven decisions based on sound data. And that's going to be important because we're taking the data, most of which we're already collecting already, and we're plugging it in. A lot of times with the help of AI or even just manually, we can take that data and plug it into the system and really start to develop some predictive capabilities for our water system, and that's going to save us a lot on our resources and the finances, because everybody knows emergency repairs are the most expensive types of repairs. So predictive maintenance, just looking at a definition, and this is kind of a low key definition here. Predictive maintenance is really about using trends in your asset related data to identify issues early before they become a problem. So what we're doing is we're looking at predictive maintenance. So we're predicting how things are going, proactive. So you're going beyond what typically a lot of small water systems are doing now. We're reacting to things. Things break or they're in imminent danger of breaking, and we're throwing our resources at that. That tends to be the least efficient way of using your staff, and it also costs more money because things never break when they're supposed to. It's usually midnight on Christmas Eve or something like that when things are going to be really expensive. So the step beyond reactive maintenance then is preventive maintenance, where we're doing things on a schedule and we're really kind of trying to maintain things, and that's infinitely better than reactive maintenance. However, we can allocate our resources best by doing predictive maintenance, where we're really looking at those assets that are destined to fail in a short term. And now we can go in and we can replace them, repair them, upgrade them, whatever we need to do to get them back in working order. And now we're predicting those failure modes. And that's how we're going to really leverage the resources we have. So we're going from reactive maintenance to preventive maintenance, and now we're getting into predictive maintenance. Like I say, this is all within the realm of small water utilities now. It used to be out of their reach before, but it's getting easier and easier to do, especially with the advent of AI. So we're really looking at moving moving a lot of small water systems that we work with to predictive maintenance. Relatively easy to do. We'll walk you through the steps here and then show you how to do the spreadsheet. All right. The key benefits of predictive maintenance are it prevents unplanned downtime, it saves on repair costs, extends asset lives, and improves water quality reliability. So, some very important factors here. Step number one, then, is asset risk ranking. So, you're going to want to start with your key assets. You don't want to take all your assets, start small, and you're going to hear this theme throughout. Start small, prove it out, and then you start adding in other assets that are less important. But start with your key assets. And we're going to look at a couple different things here. We're going to look at the probability of failure, and we're going to look at the consequence of failure. You're going to score both of those. You're going to put it on a grid, and you're going to score both of those on a ranking of 1 to 5. And then what you're going to do is you're going to end up with the risk factor, and that's going to be probability of failure multiplied by consequence of failure. And then you're going to get a number somewhere between 0 and 25. And the higher the number, the more critical it is to look at that asset and do some maintenance now. So those are what we're going to look at, and they're two separate things. You got the probability of failure, so how likely is it that asset to fail, and then you have the consequence of failure. So a high consequence of failure, for instance, would be something where it would shut down your system immediately, and you would not be pumping any water out and put water into the distribution lines. And then that phone starts ringing with people that don't have any water pressure and wonder what's going on. A low consequence of failure is something that can fail that's not going to affect the operation. You can easily switch to another unit. You have some redundancy built in and things like that. So, and then the probability of failure, obviously, you're going to look at factors like how old that asset is, what its asset expected life is, where it is in that process, and then how it's been maintained and things like that. If it's got a long asset life, but it has not been well maintained, then that probability of failure may go up because it has not been properly maintained, and so we got to look at those things. So those are going to be some judgment calls, but you're going to be able to then plug the numbers in and do this on a scientific basis. So what does that look like really? So this is our grid. So we end up with our business risk factor, and that is consequence of failure times probability of failure. You have a 5x5 grid here. So you're going from 0 to 25. And so your highest risk is going to be in your upper right-hand corner. Your lowest risk is going to be in your lower left-hand corner. So you can plot things up so you can see this visually. And you can actually take your spreadsheet and with AI, plug in AI, and it'll plot these things up for you where it falls on this chart in terms of business risk failure, multiplying the consequence of failure and the probability of failure and where it shows on there. And now you're going to be able to prioritize your assets based on that business risk failure factor. And we'll look at that a little bit later in the spreadsheet. All right, step number one, and this actually should be step number two, I guess, but simple data collection. So SCADA data can be collected via automation. You can take your SCADA data and now you can link back in and put it into a spreadsheet. And then so automatically it dumps your data in there and you're going to be able to collect that data. Or we can do manual data collection. That's going to be something that you're already probably doing anyway. So, but take advantage of SCADA and automation where you can collect that SCADA data. You're collecting it anyway. If you have a SCADA system in place, that's going to provide you a lot of good data. And there's opportunities in a lot of cases. A lot of these small SCADA systems are pretty darn affordable. They keep the data in the cloud, but you can then export that data. You can get additional modules for the SCADA system to monitor other things, and the expense of that really is not that high, but the fact is then you're collecting useful data that's going to allow you to really step up your game with predictive maintenance. And if you have to do manual data collection, you can put that in the spreadsheet as well. So automate what you can and then take everything else manually and put that in. All right. Common data points we want to look at. And once again, like I said, start small, start with your key assets, and then start collecting these data points that we're going to get into our spreadsheet and our dashboard so we can measure these things. So some examples would be well drawdown or specific capacity. That's going to tell you when you need to basically rehab your well. Pump vibration is one way where you can tell if your bearings are going out and you may need to overhaul the pump. That's especially true on line shaft turbine pumps. Chlorine residuals, your chemical feed. Sometimes these things go out of calibration or they go out of whack. So seeing how much variation you have there, tank levels, pressure trends at the pumps. These are all things to track, and they can tell you basically when you're starting to have problems. And then you're also going to want to look at what the variation is against what kind of standard you have. Basically, taking something like specific capacity, for instance, the beginning of your well, when it's a new well, you should have your maximum specific capacity. Now you can start to measure things against that starting number, or say the specific capacity right after you did a rehab. Now we have that starting point for our specific capacity. If we start declining, maybe say 15% on the specific capacity, now it's time to start looking at well rehab, and so you can get ahead of the game. So now you're predicting when you're going to lose enough specific capacity in the well that you're going to basically need to rehab it, and you're going to lose flow if you don't. And sometimes the well will just seal up if you don't rehab enough time. So we really want to look at those numbers, measure those, and that's going to take drawdown. It's going to take how much drawdown you have, which is static water level minus pumping water level, and your discharge rate. Specific capacity is very easy to do and calculate. You just have to know what your drawdown is the well and what you're pumping, and make that calculation. So specific capacity is really gallons per foot of drawdown in the well. And as the well starts to plug up and needs rehabilitation, that specific capacity number will go down. So that's a good example of data that's easy to collect. You plug it in, you track the trends in your dashboard, and that'll predict for you when you're going to need to do the well rehab. All right, so this is basically what this looks like. You got a choice. You can combine these. You can take your SCADA data, put it in an Excel dashboard or Google Sheets dashboard, whatever you're doing, and then you can create a dashboard from that so that you can see the information at a glance. So a dashboard should be set up where you're color coding things. There's conditional formatting based on your parameters and what the standards are, and you're going to compare it to those, and then that's going to tell you where you're out of whack. And then so that in conjunction with your business risk factor, which is probability of failure times consequence of failure, now you're going to start to look at how you can prioritize your maintenance. And then for those things you don't have SCADA data for, you can do manual entry and combine those into that one spreadsheet. And then basically you're going to have a front page. It's going to be a dashboard, and that's going to be able to tell you at a glance how your system is operating and where you start needing to do the maintenance. All right, so step 3 is our dashboard setup. We're going to use color coding. Make it simple so you can look at it at a glance, and you're going to use green, yellow, red, and those are going to give you your usual, okay, need some work, and then critical. And so you're going to be able to tell at a glance on that. You're going to want to auto-calculate the risk scores and alert levels. So as that data goes in there, there's going to be some calculations in the spreadsheet that should automatically calculate those for you. And now you're going to be able to tell what your risk scores are. And then when you're getting into the alert levels rates. You can also keep a maintenance log in there too. So what maintenance has been done. So that's easily accessible. And this spreadsheet and dashboard can be shared throughout the water utility, and so that everybody can see what's happening at a glance. So, and the maintenance log will tell you what's recently been done and what your observations are, and that enters into your consequence or your probability of failure too. Because if you're seeing some things going on and it ups your odds on your probability of failure, then you're probably going to want to update that information in your spreadsheet. And then we're also going to look at the schedule of the next service on that. And that can change based on the criticality of your calculations, so your alert level. So this is going to be a little bit of a fluid system, because what you're doing is you're predicting and getting ahead of the failure levels on these systems. Um, so basically, what you're going to do is you're going to create the spreadsheet and the dashboard and track things there, and it's going to be visually something that you're going to be able to look at a glance. Now, this one here, I noticed the colors are a little off here, but you kind of get the idea. Here is you got your asset, your risk level, you got alerts there, you have your chart there, and I kind of like the speedometer style charts a little bit. It kind of helps see where you're going there, but you can do graphical ones too to look at your long-term trends, and probably both. What is your current level compared to your standard, and then what are your trends? Trends are very important, because trends are going to allow you to project out where you're going to need maintenance and where failure is going to happen. So plotting up the trends is going to be very important. So both the current state of the asset, which is your dial here, and then your little alerts there, and then also your graphs are going to show the trends. And you got to look at the trends too. It's very important. All right. Step 4, use the data trends. So in decreasing specific capacity, if you reach a certain point, you're going to have impending well rehabilitation as an example. You have increased pump vibration. So you're going to measure pump vibrations. And so you reach a certain threshold, and you're going to want to overhaul the pump and change out the bearings. So these are a couple examples here. You can probably think of more, but these are just some examples we can track. So you want to use the data you have. You collect the data regularly, and you use that data. This is just an example of how we might chart up pump vibrations. So you have a threshold plotted up here. You can see the trend here. We're starting to inch up to where our vibrations are increasing, which indicates that we probably have some bearing issues. They're flattening out and they're getting worn out. And that pump probably needs to be overhauled because we're hitting our threshold here. So you can see, very simple. You can look at it at a glance, see where you're at, and this is pretty darn easy to do. All right, so step 5, act on the data. When your system flags a problem, act on it. Maintenance should be planned, not reactive. So remember our chart earlier, going from reactive to proactive to predictive maintenance. This is really how we want to do it. We want to get ahead of things, and so you're not doing maintenance when things fail. We don't run to failure. That is the most expensive mode and the most staff-intensive mode that we can think of. So we really want to get ahead of things, do the maintenance, the overhauls, those types of things before they become a problem. So having that data there is going to allow us to act on that data. All right, and this is kind of how you're going to want to look here. So you're going to want to detect your trends here. So you're going to want to identify your problems. This is in the yellow here, indicating potential issues. You want to then schedule maintenance. So we're going to the orange here. So plan interventions to address the detected trends. So if you got a problem, you're going to want to jump on that right away, because the probability of failure is starting to go up, and you want to deal with that as quickly as possible. And now we're going to jump on things, and that's the green here. We want to avoid disruptions by addressing the issues early. And then that cycles back around again. So we're going to start looking at the trends again And so your long-term trends, then once you fix things, you get that vibration down in the pumps, and your charge is gonna be back down again, and then you're gonna start that trend up again. And so that's always looking at the data and making data-driven decisions. Very important. All right. So step 6, start small and expand. We want to start with our 3 to 5 highest risk assets. So those are the ones that are probably most critical for you. And you're going to want to get a system in place and start looking at those assets and fine tune things as you go along. And then once you kind of get the system in place and you understand how it works and how you're collecting that data, how you're using that data, and how you're implementing the predictive maintenance program, now you can start adding assets, data sources, and analysis and start expanding out. And so you've kind of proven your system out. You got some confidence in the system. Now you can start adding in the other assets, and you can build out a pretty darn good predictive maintenance program. And you're just going to have to decide how many assets you want to add into this thing. If you want to eventually add everything, that's fine too. Um, if you want to keep it kind of medium size, where you're looking at your collection of most critical assets and or the ones that have a high consequence of failure, those are the real ones you really want to focus on, and then you can add things in as you feel comfortable. All right. Suggested phases of the predictive maintenance program. We want to do the inventory assessment of your assets and then the risk assessment. So we're looking at that. And then we're going to do our basic monitoring setup, which is going to be setting up your spreadsheet and dashboard. And now start looking at your initial predictive actions. See what the data tells you, and then determine where you are, what your threshold should be. That's the other important thing, is because you you want to look at the current state of the assets, and you want to look at what the threshold is. So a specific capacity, if you have a starting specific capacity and say it drops below 30%, that's going to be your threshold. And you're going to want to look at that as you inch down towards that specific capacity loss. Now you're going to say, okay, we're predicting that we're going to start seeing some plugging up and substantial reduction in our flow rates. We want to do well rehabilitation. And then you expand as you get confidence in your system. And now you go back and you start doing continuous improving. You start tweaking things, making little adjustments as you need to make sure the data works for you, and you're fine tuning that predictive analysis and can really stay on top of things. And ideally, you would never have any emergency repairs because you're staying on top of things. That's probably an ideal world. Things are going to fail for one reason or another, or you didn't call it quite right. But you can substantially reduce the number of emergency repairs, maximizing your staff times and saving on your financial resources as well. So, all right. So here's our roadmap: inventory, plan, refine, and act. And we're going to kind of go back and keep refining. So that last part is just really those last two. You're kind of recycling that because you're kind of in a loop there, because you're constantly refining, making the system better, and then you're going to keep acting on that data. And basically, the consequences of acting is going to allow you to go back and refine your system. So it's always going to be a continuous improvement process. All right. So fewer emergency repairs get you, these are real results. Fewer emergency repairs, better budgeting, more informed decisions, and more time to focus on service. So really, you're going to reduce the amount of staff time and employee time that it's going to take on doing emergency repairs. And that is really our goal here is number one here: fewer emergency repairs. It's going to save you money. It's going to save you time. It's going to allow you to budget more, because now we've got our predictive maintenance going on. We're going to know when we're going to need to spend the money, and now that's going to help our budgeting as well. So you're making the informed decisions, and then you're going to have more time to focus on the service and the things that really matter, instead of running around putting your finger in the dike. All right. So, and as an extra bonus, this predictive maintenance system links into your asset management plan. So you can tie it together and, especially the business risk factors. Now you can start looking at your asset management plan for predicting, and also this is going to tie into your capital improvement plan as well, because it's going to help you justify the funding and the capital improvements, and you're going to be able to take that to your board with real data to show them what they need to do, and they're going to be able to make better decisions as well, and make sure the proper funding is available for the capital improvement plan. And that's going to be flow from your predictive maintenance, which is going to tie into your asset management plan, which is then going to flow into your capital improvement plan. So all these things work together, and it starts with the predictive maintenance program. All right. So wouldn't you like to be able to take this to your board in your water system and show this type of real data? That would be awesome, and you're certainly gonna justify your existence by doing this, and the fact that you've created this program that is really um, uh, taken your number of breakdowns and cut them in half or more, and allowed you to do better budgeting, stay on top of the assets, and make better use of your personnel and time. So this is great when you can do this. And by having everything in a spreadsheet and graphed out, you can actually produce these charts very easily. Take them to your board meetings, and the board members are going to appreciate that. All right, so what we want to do is we want to work smarter with the data you already have. You're going to have you're really predictive maintenance doesn't really require much more data than you already have. It's just smarter use of the data you already have. All right, so let's look at a couple things. Let's look at our spreadsheet here, and we're going to go here, and let me just bring this up on my end of things here so you can see this. Um, so we have a number of, and this is just a very simple example that we just put together. You can do this yourself. We do this for people as well. We build them out a little fancier, and I'll point that out. This is just an example of a very, very simple spreadsheet, but you can see here, this is our asset and risk. This is our asset ID is here, our asset name, um, the type of asset, the location, and a lot of people will put in the GIS location, uh, the installation year, and then you get into your probability of failure and your consequence of failure, and then this will calculate for you the business risk factor. So you can see here, it's just a simple calculation, multiplying these together, and then what the condition summary is, when your last maintenance was, and the next maintenance is due. Now, next maintenance is due. It may be adjusted based on the business risk factor and some other things you're seeing out there, the condition summary. So you can adjust that. That's the beauty of predictive maintenance. All right, so let's look at some of the individual assets here. This tab is for pumps. Um, so once again, we have our date, we have the asset ID P1 for this pump one, runtime hours, vibration, uh, motor temperature, flow rate. These are just some possibilities. You may want to measure other things, discharge pressure, and then the status flag really looks at what our runtime hours is, and if it's less than 8 or greater than 8, then we want to check it, um, and or you have okay. So that's going to be our flag here. Um, Vibration is, I would probably look at using the vibration here instead of runtime hours. And then your motor temperature, you can set the standards. And probably what I do in addition to this, I would actually set the standards here. So you got something to compare to and not just build it in the formula. So it's right here on your chart as well. So well specific capacity, you got one well here, the date, the static water level, the pumping water level, and the flow rate or discharge. Drawdown is actually static water level minus the pumping water level, and so you then your flow rate then is divided by the drawdown. So we can see how our specific capacity is 19.2. In this one, we have you can see in the formula here that if our specific capacity is less than 8, then we'd give it the rehab flag here. So we're actually calculating that out. Now, specific capacity requirements and thresholds are going to be different for different wells. So you can want to I would once again add a column here instead of just having it built in the formula, and then add that in here so you can see what the standard is. Chemical feed, these are just some ideas. Your chlorine residual, your pump output, is it having problems? If you got any triggered alarms, uh, your manual reading and the difference between those readings, and then the status once again is calculating, whether the residuals are low or high or right on, and that's kind of what we want to know. And then your maintenance log. This is just going to be manually entered. Generally, is you're going to want to show what your asset ID is here, the date, the maintenance type that you did, the notes. So you got notes here all documented, who was performed by, and then the next action due. And once again, that next action due is probably going to be based on the type of notes here and any problems that are noted. And then lastly, we have a very simple dashboard here. This just takes the specific metric here, which is pump 1 vibration, well 1 specific capacity, chlorine residuals, the risk score for pump number 1. These are just some examples here, the latest value. And now we're looking at the flags here that are going to be calculated based on these latest values versus the standard. So you can, I like to do these where I'll actually do conditional formatting here. So I'll make it the green, yellow, red, and then I'll actually put over here some dials, some speedometer type dials, and then the actual data trends with a graph as well. So you can see once again at a glance what the color is, what condition it is. Then you can look at a glance and see where it sits on the speedometer and the most recent reading, and then what the overall trends are otherwise. And that's really kind of how we set up. You can make this a lot fancier. We tend to do a little bit more involved one, but this basically just gives you an idea to get going here. So now, once you have your dashboard in place, the one thing we can do is we can start looking at our preventive maintenance program and start documenting that for our staff. So make sure everybody's on the same page. And this is just an example here of a one-page utility staff guide reference for people in the water system. So it gives you the purpose here, and it lays out the daily or weekly tasks. So you can see that here. You can see your monthly tasks and who's responsible, and then you can see your quarterly tasks. So this is just basically a one pager that's going to let everybody know who's responsible for doing what and when. And you can see on here what our monitoring tasks are, what the red flags are, and what actions we want to log. And if you want to get a little more in detail than that, then we can actually go to standard operating procedure. So this is an example of an SOP outline, and this is going to be a little bit more detailed. And I actually recommend that you have best business management practices and then standard operating procedures, because ultimately we want to build an overall system and processes that are going to guide what we do and really have us running like a finely tuned watch and make it running like clockwork. And that's really what we want to do. SOPs are a way to make sure that everybody's on the same page and doing exactly the same thing. So let's look at this is just a template for an SOP for a predictive maintenance program. You can see the header here, who it's prepared by, approved by, what version number, so you know you're always operating with the current one, the effective date, and then you look at the purpose. What's the purpose of this? Then we go to the scope. This applies to all critical operational assets, including water supply wells, well pumps, and all these things, valves, flow meters. These are what the SOP applies to. It's always helpful in SOP for especially for new people coming on. Our definitions here, so we can see our definition of probability of failure, consequence of failure, predictive maintenance, or SCADA system. These are just some examples here. You might want to have something in there. What's business risk failure or business risk factors and things like that. But any definitions you think might be helpful. And then we go to our roles and responsibilities. So, who's responsible for what? The operator's responsible for this, the maintenance lead, supervisor, manager. These are all the responsibility under this SOP. Equipment and resources. This is what equipment we're actually interested in here. So, SCADA system that's available, our predictive maintenance spreadsheet. These are all the things you're going to be using in the predictive maintenance mode. So that's something you want to look at here. Our field logs, SOP binder, just so you got everything in hand. And then the heart of the SOP obviously is the procedure. And we kind of step through the steps. We just talked about the asset inventory and risk ranking, data collection and entry, condition monitoring and flagging, your maintenance logging, your dashboard review, and your reporting and backup. So these are the steps you walk through in the SOP. And then what kind of documentation and records we're going to get out of this as well. So maintenance logs, risk register, dashboard printouts or screenshots for meeting notes, annual summary reports for the board or the public works director. So these are the documentations you're going to produce as a result of the work that was done under the SOP. Safety and compliance, we always got to have that. And then here's a section on continuous improvement. What do we need to do to keep tweaking the data and making it better? So, and then lastly, you're generally SOPs are going to have some references, so we know they're standardized to industry publications. So that's where you plug them in there. So that is your SOP, and I highly recommend that as you go through this, your asset management plan, your capital improvement plan, and your and the rest of your processes, that all your processes that you develop in your system for your utility. And I highly recommend predictive maintenance is only part of this. I highly recommend you systematize your entire utility, but the SOP is going to be a big part of that, because that's going to tell you how to actually be consistent in all your different components of your system. So SOPs are highly recommended. All right, so that is the show today. Hopefully you got something useful out of it. I want to remind everybody we have coming up our Water Masters Mastermind. This is a 12-month program for small water systems of less than 3,000 connections. That's going to be, we're going to cover basically everything on management for small water system predictive maintenance. We're going to dive into it in greater detail, how it ties into the asset management plan, dive into the asset management plan spreadsheets, capital improvement plans. There's a lot of different components and working parts of that go into that. So if you'd like to be a part of that when we get it going here, email me at tballard at sehydrogeology.com. That is my email, and I'd love to hear from you on that. So with that, we're ending here, and this is the end of the program. Thank you very much for watching. We'll see you next week.